Hello, this lesson is on Advanced Functions, Grade 12. My textbook is published by McGraw-Hill Ryerson. We begin with Chapter 1, Section 1. Chapter 1, Section 1 talks about power functions. First of all, what are power functions? Power functions has a general form. An unknown goes to a power, or you can say exponent. For example, this is a power function. Let me make this bigger. R is a variable, and R goes to power 3. Pi is a constant. 4/3 is also a constant. So I have a constant multiply an unknown. The unknown goes to a power. This is called a power function. Here, power function. There is another name called polynomial function. What is a polynomial function? This is a sum of many power functions. A sum of many terms. Each term looks like this. So a polynomial function looks like this. Polynomial expression is an expression of the form here. So each term is a power expression. So this is a power, you see? Constant and a power function. Power. So polynomial expression is a sum of many power functions. I need to explain the word expression and function. An expression contains variable only. Now here, the book uses the word expression because x is a variable. And all the a's, a here, a, all the a's are constant. So I have a sum of many terms, and I contain in this sum of many terms, the variable is x. So I call this expression. But what is a function? This is a function. Look, the right-hand side is expression. And you use a label to represent this expression. If you do that, you call this function. So the function has left-hand side and the right-hand side. The left-hand side is just a label, or you can say notation. So this left-hand side, you can call it a function notation. It's just a label. The whole thing is a function. So you have a label and an expression here. So this is an expression. Because there is no left-hand side, actually there is no equal sign. There is no equal sign, okay? All right. There is another name called coefficients. What are the coefficients? We go to the polynomial expression. These a's, a here, a, the many a's, these a's are called coefficients. For polynomial, the coefficients must be real numbers. All the a's are real numbers. Otherwise, you cannot call it a polynomial. Okay, it has to be real numbers. Another word is degree. What is degree? Degree is the exponent of the greatest power of x. So this is a polynomial expression. What is the degree? The degree is n, because that's the greatest power. All these powers are one less now, two less, and so on. So the degree is this. N is a whole number. Actually, it's not just a whole number. It has to be a positive number, because whole number can be -1, -2, -3. You cannot have a negative here. N is not negative. In addition, n cannot be decimal. Okay, because this is, n has to be a whole number. So it cannot be a decimal, it cannot be negative, and also it cannot be a fraction. N cannot be a fraction, because a fraction is not a whole number. And also, I said n must be positive. So if you have negative exponent, then it is not a polynomial. Okay, we explained what are coefficients, what is the name degree. Another name is called the leading coefficient. All the a's are called coefficients. One of the a's is called the leading coefficient. The leading coefficient is the a's before the highest exponent. If this exponent is the greatest, all the other exponents are less than that, then this a is called leading coefficient. Now here the book tells you the polynomial function. Now we use the word function. You see, the function has a left-hand side and also has an equal sign. Now here, the expression has no equal sign, no left-hand side. Okay, so that's the first page. Next, we have some investigation. So let me make this Okay. Here, in this investigation, I have A, B, C, D, E, F. I have 1, 2, 3, 4, 5, 6. I have 6 functions here now. And the exponent goes from 1, 2, 3, 4, 5, 6. The question is, which function is represented by which graph? I have 1, 2, 3, 4, 5, 6. 6 graphs. Which function is which graph? Give me a minute because my camera need a power supply. Give me a minute. Okay. Okay. Sorry, I keep you waiting. Okay, that's fine. Now, how do we decide which function is represented by which graph? Y equals x. You know that this is a straight line because this function agrees with the basic form of the straight line y equals mx plus b. So in this case, m is 1, b is 0. So the y-intercept is 0, the slope is 1. So this is a straight line. So which graph is a straight line? Here. The slope is 1, the y-intercept is 0. So A is this graph. How about B? You are very familiar with B because this is a quadratic function. Power 2, it's a quadratic function. A quadratic function, the graph is a parabola. Okay, this looks like a parabola. This looks like a parabola. And this looks like a parabola. Which one is y equals h squared? So it's easy. If x is 1, 1 squared is 1. So if x is 1, y is 1. That is B. Okay. This is x is 1, but y is not 1. So not this one. Let's go to, I said this is a parabola. You don't need to check that. That is not a parabola. So this looks like a parabola, but when x is 1, y is very small. It's not 1, so it's not this. Next one looks like a parabola is this. And you look at this. When x is 1, y is not 1, so it's not this. So next graph, parabola like this looks like a parabola. When x is 1, y is 1. So this is the graph of the second one. The third one, when x is 1, y is also 1. But then this is not this, because this is cubed. So you look at, if x is 2, y has to be 2 times 2 times 2 is 8. So when x is 2, y is 8. When x is 2, y is 8. No, this is 32. No. First of all, this is not a parabola, so I don't need to check this. When x is 2, y is 8. So it should be this, except I have 2, 4, 6, 8 is here. So it looks like that. Okay. So I should say this is the third one, C. The third one. D, when x is 2, 2 to the power 4 is 16. When x is 2, it is 16. So which one is that? When x is 2, is 16. Oh, it's this one, you see? When x is 2, y is this. But this is half of 32, so it's 16. So it's this graph. It's this graph. Next. The exponent is 5. When x is 2, then it is 32. When x is 2, this one. When x is 2, y is 32. So which one is that? Oh, this is the first one, you see? When x is 2, y is 32. So it's the first one. The next one is when x is 2, is 64. Okay, it is this one. When x is 2, it's 64. So this is how you decide which function is which graph. This is investigate. Let's go to here. Okay. Two more names. One is called line symmetry. What is line symmetry? Look at this graph. This graph is symmetrical with respect to the dotted line, which means this half and this half are mirror image. So this line is the line of symmetry. So the graph has line symmetry. Another term is called point symmetry. What is point symmetry? Look at this graph. Look at this point. If you turn 180 degrees, turn this point 180 degrees about this point. So you turn about this point. So you turn, or you come to another point. Which point? That point is still on the graph. So if you have this property, this point is the point of symmetry. So the graph has point symmetry. So remember, point symmetry, you need a point, and if you turn any point on the graph, turn that point 180 degrees, you get to another point on the graph. Then it is called point symmetry. All right? Okay. So next we talk about an example. Example 1. Example 1, I just explain this. Example 1, you have ABCD functions. 4, 1, 2, 3, 4. You have 4 functions. And the question wants you to say, are these 4 functions polynomial functions, or some of them are not? So some of them may be polynomial functions, and some of the other ones may not be polynomial function. What about A? Is this a polynomial function? No, it is not a polynomial function because it doesn't agree with the general form of the polynomial function. In fact, this is a trigonometric function. This one, is this a polynomial function? Yes, because this agrees with the general form. This part is called A, and this is a variable. This is the exponent. What is the leading coefficient of this polynomial function? The leading coefficient is -2. What is the degree of the polynomial function? The degree is 4. Next, this is a polynomial function. This agrees with the general form of the polynomial function. What is the degree? You look at the degree here, 3, 2, 1, and this is degree 0. So the highest is 3, so the degree is 3. Remember, degree is the highest value of the exponent. So degree is 3. Once you have the highest degree here, so what is the leading coefficient? It is this number. So the leading coefficient is 1. The next, is this a polynomial function? No, it is not a polynomial function because it doesn't agree with the general form of the polynomial function. In fact, it is an exponential function. So that is this example. Okay, so let's go to the next. So next we have example 2. Example 2, you want to answer what is the domain, what is the range, and the end behavior, symmetry. All right. First, let's answer domain and range. Domain refers to x values. Range refers to y values. So look at the first picture. What is the domain? You see the x value, you can have all the x values. X values here, x values are negative, but you have y value. So your x values here are positive, and for each positive x value, you have y value. So the domain is all real numbers. The range is all the real number. So that's the answer there. So for the second picture, what is the domain? Domain, x can be negative, can be positive. So the domain is all real numbers. What is the range? Range means y, and you see y. The graph is above the x-axis. Therefore, y is positive. Y is larger than 0. And here, this point, y is 0. So y is larger than 0 or equal to 0. That's the range. For the last graph, what's the domain? Domain is x value. You can have all the different x values. So domain is all real numbers. And how about range? Range is all y values. You can have all different y values. Okay, this is example 2. Oh, not yet. The example 2, you want to describe the end behavior. So how do I describe the end behavior? You trace the graph from the left side to the right side. So you trace like this. So you start from the second quadrant and you end at the third quadrant. So the end behavior is from second quadrant to, this is the third. 1, 2, 3, 4. You start from second quadrant, you end at fourth quadrant. That's called end behavior. For this one, you start from second quadrant, you end at the first quadrant. So from second quadrant to first quadrant, that's the end behavior. And this one, 1, 2, 3, 4. So you start from the third quadrant, you end at the first quadrant. That's the end behavior. Now the third part is called symmetry. Is there a symmetry here? Yes, it's point symmetry. Because you look at this point, you turn 180 degrees, you end up here. So this point is still on the graph, so it's point symmetry. You turn this 180 degrees, it goes to here. So it's point symmetry. This one is very obvious. It's symmetrical with respect to the y-axis. So it's a line symmetry. This line is the line of symmetry. This part and this part are mirror image about this line. How about this one? This has a point symmetry. So you look at any point, says, look at this point, you turn 180 degrees, you end up here. So it has a point symmetry. Okay. Now example 3.